All right, hello boys and girls. Today in this video we're going to review covalent compounds and covalent nomenclature. So I want to remind you that in a covalent compound, two nonmetals are sharing electrons. This is important that you know this, okay? So since they're sharing, there are no charges happening here. They're sharing. Someone's not losing and gaining to create a positive and negative ion like in an ionic compound. They're sharing electrons. And so I don't want you to think about balancing any charge. What's the key to covalent compounds? Prefixes is the key. We'll talk about those in a minute. Now, how do two nonmetals share electrons? Well, let's look at water. Water's cool. It's sort of helpful. Water has an oxygen in it, which has 6 valence electrons. All the elements in 6A or 16 have 6 valence electrons. And hydrogen has 1 electron. And we're going to put another hydrogen over here with 1 electron because you know that water is H2O. All right, so if this oxygen and this hydrogen share those 2 electrons, and this oxygen and this hydrogen share those 2 electrons, let's count electrons and see what happens there. So first off, let's count the electrons around oxygen. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen ends up with 8 valence electrons when it's sharing those pairs with those hydrogens. And so the electrons in the circles here can be thought of as being attributed to the oxygen or to the hydrogen, whichever way you want. All right, let's take my numbering out. So oxygen's happy, it has 8. What about the hydrogens? Well, this hydrogen has 1, 2 valence electrons. It is still happy because that gives it a configuration like helium, that full outer energy level. So that's cool. So that hydrogen is happy. 1, 2, and then this hydrogen is happy. So what you see is that everyone ends up with a full outer energy level, and it's stable. No charges, no losing or gaining, just sharing. Cool, huh? Cool. All right, let's talk a little bit about the nomenclature now. The first thing you know is that prefixes are everything. So make sure you know your prefixes. I'm going to do them in order: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So memorize those prefixes yesterday. Get it yesterday like you should have already done it. Okay, next, let's look at a couple rules. Rule number 1, don't write mono before the first nonmetal. You can write it before the second, but don't write it before the first. Prefixes indicate subscripts or the number of atoms present. I'm going to put that in parentheses. Number of atoms present. Cool, huh? Yes, say cool. Say cool to your computer. Say, computer, that is cool. All right. And remember to change the second nonmetal. Change the ending of it to IDE. All right, so now I'm going to do about 10 examples, and then we're done with this. So if the problem says N2O5, what's the answer? Well, you say, okay, this is 2 nonmetals, so this must be covalent. I've got 2 nitrogen, so I'm going to say dinitrogen. And I've got 5 oxygen, so I'm going to say pent. In this case, you drop the A, pent oxide. Dinitrogen pentoxide. Di means 2 nitrogens. Pent means 5 oxygens. Whoops, 5 oxygens. That's all there is to it. Now remember, how did I know to do that initially? I knew to do that initially. I knew to look at the prefixes because I noticed that it was 2 nonmetals, and so it had to be covalent. How about this one? So I want to say monocarbon, but then I remember that rule that says I can't write mono at the beginning, so I'm just going to leave it at carbon. And I have 1 oxygen, so I am going to call that one monoxide. That's carbon monoxide. Cool, huh? Right? What if it's backwards? What if it said carbon tetrachloride? Tetrachloride. Carbon tetrachloride. You would say, okay, there's nothing in front of carbon. That means that there's one present. You see tetra, that means that there are four present. So I'd say C1Cl4. Remember, don't write the ones. The ones are understood. Yay! 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 Yippee! Yippee! Yo! All right. Another example. You say, another example, please, Mr. Walker? Sure. Let's do N3S10. Whoa! 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 Try for 3. Nitrogen. 10 is deca, and not sulfur, but sulfide. I think that's probably enough examples. I guess I'll do one more where I give you the formula. This one comes up a lot. Sulfur trioxide. So in front of sulfur there's nothing. That means 1. Tri means 3. So I'm going to write S1, O for oxygen, 3. No charges, no balancing, just looking at the prefixes and going with it. That's the end. Remember that covalent is always made of 2 non-metals. Ooh, I just remembered one more little thing. And remember that metalloids are like non-metals here. So SiO2 will be silicon. Even though it's a metalloid, we're going to treat it like a non-metal dioxide in our name. Alrighty? Alrighty.